Today we'll be doing an experiment of a lemon battery. And first, we will roll the lemon onto the table to make it softer and let the juices out so it's easier to poke. And next, we will do an incision into the lemon using a pair of pliers. And this will be the end where the copper coin will be put in. And now the zinc nail will be inserted on the other end. So now we will test for the voltage and see which side is the positive or the negative terminal. So according to this, the positive end is the coin, whereas the negative end is the nail. There. It's giving a reading of 0.393 volts. Thus we can conclude that the nail is the negative terminal and the coin is the positive terminal. Alright, so here we have one lemon, and now we will check for the voltage of one lemon across its terminals with a DMM. And we have 0.425 volts. Alright, so now we will attempt to connect an LED to the lemon. So the positive end goes to the coin and the negative end goes to the nail. And as you can see, the voltage is too low and thus the LED doesn't light up. Okay, so here we have two lemons connected in series, and now we will check the voltage using a DMM. And it's 0.808 volts. And now we will attempt to connect the LED to the two lemons. And as you can see, the LED doesn't light up due to the low amount of voltage. Alright, so here we have 5 lemons connected in series, and we have connected them in series to increase the amount of voltage that can be delivered. And so after testing it with the DMM, we have around 2.145 volts. Alright, so here we have the 5 lemons connected in series, and now we have attached an LED to it. The positive end is connected to the coin at the other side, and the negative end is connected to the zinc nail. And now we will connect it at the other ends to see if it will light up. And there you go. You can see the flicker? Yeah. Alright, so it works. Alright, so this is a setup where we have used like full lemons and we've cut them up into different quarters. And here we've used 5 quarters. And here, each quarter acts as its own battery. And yeah, be careful when you're cutting it, because you might get injured. And the space between each lemon has to be dry, because the lemon juice that might be present might actually affect the output of the voltage. And here we're going to try and test out the voltage. Alright, so as you can see, the voltage across these cut up lemons is about 1.675 volts. Lemon battery is called a voltaic battery, and it changes chemical energy into electrical energy. This battery that we're using here is made up of 2 different metals, which are the terminals. The positive terminal is a copper coin, and the negative terminal is the zinc nail. And the electrolyte is the acid within the lemon. And for example, in a solution of water or an electrolyte like the acid in this lemon, an excess of electrons collects on one end of the electrodes. At the same time, electrons are lost from the other electrode, and thus electricity can flow through it, and thus it's a conductor.